You're doing this. All right. So happy Tuesday, everyone. Hope you're all having a fantastic day. Today, we're doing some super fun stuff. We're going to talk about z-scores. We're going to interpret quartiles and determine what they are. We're going to talk about the interquartile range and look for some outliers. And then we are also going to do something called the 5-number summary, and we're going to make some box plots. So most of the beginning of our class is going to be talking about the mean and the standard deviation. And then we are going to move on to median and talk about all of the ways that we can look at data with median. And then we're going to go through lab 2. We're going to work through that together. So before I lose the computer, I'm going to try to make it so that I can share, allow other people to share, because if I don't do that, then I'm going to have issues, because then when I lose my, there we go. So when I lose my, my internet, or when I lose my computer, I want to make sure that I can still share on my other computer. All right, so let's get going. Okay, so what a z-score is. What a z-score is it is the how many standard deviations something is from the mean. So it's basically a distance. I wish this thing would go away. This little box here. Let's just move it. Okay. So what a z-score is, it is a distance that a data value is from the mean in terms of standard deviations. So we know that 68% of our data is within one standard deviation of the mean. So one standard deviation above the mean would have a z-score of 1, because it is one standard deviation away. A z-score that is one standard deviation below the mean would have a z-score, or a value 1 standard deviation below the mean would have a z-score of -1, because it is still 1 away, 1 standard deviation away, but it is in the negative side. Same thing with the 95%, which is 2 standard deviations away from the mean. So as we know, 95% of our data is within 2 standard deviations of the mean. So if I go up to the top of that, since I had to add the standard deviation twice to get there, that z-score is 2. Same thing, negative, since I had to subtract 2 standard deviations to get to the lower one, that z-score would be -2. So that's what z-scores are. And this right here is not the right. This should be sigma, not mu. I keep forgetting to change that. So when we are calculating the population z-score, so the calculations are exactly the same. It is just the symbols that are different. So for the population z-score, it is your data value minus the mean, well, minus mu, divided by sigma. So it's x minus mean divided by the standard deviation. It's the same thing with sample. We just use the other symbols. So x minus x bar divided by s, x minus the mean divided by the standard deviation. We're going to do some math with that, and hopefully that'll help you. So as a reminder, any value that is more than 2 standard deviations away from the mean is considered an outlier. So if you get a z-score that is 2 or that is greater than 2 or lower than -2, those would be outliers. All right, let's move on. So let's take a look at using the z-scores. A lot of times we use the z-scores in order to kind of standardize something. So comparing 2 things that have different means and standard deviations, it's really hard to compare them unless you convert them all to z-scores. So let's use this example. So the mean height of males 20 years or older is 69 inches, which is 5'9", 0.1, with a standard deviation of 2.8 inches. The mean height of females 20 years or older is 63.7 inches, with a standard deviation of 2.7 inches. So we want to know who is relatively taller, Kevin Garnett, who's 83 inches tall, or Candace Parker, who's 76 inches tall. So we're going to calculate both of these z-scores and then determine who is relatively taller. So let's get a color here. Okay, so Kevin Garnett, I'm going to take his data value, so his 83, subtract the mean, which is 69.1, then divide it by the standard deviation. If you put all of this in your calculator at the same time, you need to put parentheses around your numerator. Otherwise, you're going to get the wrong answer. So when I put this in, I'm going to put in parenthesis 83 minus 69.1, close my parenthesis, then divided by 2.8. His z-score is 4.96. That is a crazy outlier, considering that an outlier is any value more than 2 standard deviations from the mean. He's almost 5 standard deviations from the mean. All right, so let's take a look at Candace Parker. So we do 76, which is her data value, minus the mean, which is 63.7 inches, and divide it by the standard deviation of 2.7. Once again, remember, you need to make sure to put parentheses around the numerator. So I'm going to do that right now. 76 minus 63.7 divided by 2.7. Her z-score is 4.56. So clearly she is also an outlier, but his z-score is higher, which means his height is more standard deviations away from the mean than her height is. Therefore, Kevin Garnett is relatively taller. Questions? All right, move on to the next one. Okay. So this is the same thing. This stuff got you bad on the homework? You managed to delete all those? I can't show you right now, but I will show you at the end. I can tell you that's why I said hit clear, not delete. This is why I say don't hit delete. I will show you later. All right. So the Angels scored 773 runs and play in the American League, where the mean number of runs scored is 677.4, and the standard deviation is 51.7. The Rockies, you can, as long as it's not due yet, you can't redo anything that's past due. You can re-upload a new hand-in homework if you want, because it's due tonight, but you cannot fix, redo anything past due. But yeah, you can just upload a new one and I'll look at the newest one. All right. So the Rockies scored 755 runs and they play in the National League. The mean there is 640 and the standard deviation is 55.9. So we want to calculate the z-scores for both the Angels and the Rockies. So I'm going to put this formula right up here. So remember, it is x minus mu divided by the standard deviation. So I would like you to start ahead of me and I will quietly work behind you. I'm going to give you a head start.
Because I shouldn't have wiped off the sheet with freaking the water that soaked into the bed. Look how dark spot on the bed now.
Okay. Somebody needs to mute themselves. I don't know who it is that's speaking. Thank you. Okay. All right. So I don't know if you all have yours yet. Yeah, mine's starting to slow down. The computer's starting to be sad. So for the Angels, I got a Z-score of 1.89. They had a pretty good year, but they're definitely not quite an outlier. The Rockies, however, look at their Z-score. Their Z-score is 2.057. Even though they scored fewer runs than the Angels, their Z-score is higher. So relatively, they did better. So their score is an outlier because it is greater than 2 standard deviations away from the mean. So the Rockies had a really good year. Are there any questions on this? This makes sense what Z-scores are? All right, we'll move on. Okay, so let's talk about quartiles. Let's talk about median. Your Z-score for, hold on, for Angels? Okay, I might have mathed it wrong. Let me try it. Let me see. 677.4. No, my math looks correct. Did anybody else? You know what? That's what mine says. I just wrote the wrong thing. I apologize. I saw the 9 and I just wrote the wrong thing. There we go. Now it's in the wrong color, but it's there. Sorry about that. Sorry about that. You guys are right. I am wrong. Okay. Now, let's jump into quartiles. See how much we can get before my computer decides it wants to die. We are at 28%. All right. So we use quartiles only when we are dealing with median. I'm going to say that one more time because every term we end up with some confusion there. We only use quartiles when we are dealing with median, not with anything else, just median. So the way that quartiles work is you find your median. Then quartile 1 is basically the median of the bottom half of your data. So it divides the bottom half into 2 pieces so that 25% of the data is below that quartile 1 and 25% of the data is between quartile 1 and the median. So to find quartile 3, you take the upper half of your data above the median and you divide it in half so that 25% of your data is between quartile 2 and quartile 3. And then 25% of your data is between quartile 3 and the top. So this just splits all of my data into fourths. This diagram down here is pretty helpful with that. So all of the data is separated into fourths, and it kind of helps us to work with it, and it helps us to create box plots, which we're going to do in a little bit, which we're probably going to be doing on my other computer because this one might not make it. All right. So you have to make sure before you start finding your quartiles that you arrange your data in ascending order, so smallest to largest. So the data goes smallest to largest. Then you find the median. After you find the median, oh yeah, but that diagram, yeah, it does come in really handy. After you find the median, you find basically it's the median of the bottom half. And that gives you quartile 1. Then you find the median of the top half, which is quartile 3. And we're going to do an example and hopefully it will be helpful. We're good at finding medians. So we can find medians, do 3 times for the data set. We are good. Okay. Here is, I put these in ascending order already, so we don't have to deal with it. This is the speed of vehicles that are going through a construction zone on a state highway. There are 14 randomly selected vehicles that are going through a construction zone, and we're going to find the quartiles. So since there are 14, it's even. We're going to find our median smack dab in between the 7th and the 8th value. So 1, 2, 3, 4, 5, 6, 7. So my median, whoa, I need to put a pen on. My median is right here at 32.5. That would be my median. Now to find quartile 1, we take the median of the lower half. So I have 7 values in the lower half. So the median will be the center value. So, or the quartile 1 would be the center value. So this right here would be Q1. Once again, upper half has 7 data values. And so we need to find the median of those seven data values. So it's the one smack dab in the middle. So it is this one right here, and this is Q3. And all that this really means by interpret is that we would say, so 25% of my data is up here, is right here. 25% of my data, and I lost a 5. 25% of my data is right here. 25% is here, and 25% is here. That's really all that they're wanting us to do with the interpretation. So it just splits it into 4 sections. Questions on that? Questions? All right. So this is my interpretation. 25% of the speeds are less than or equal to 28 miles per hour, which is the first quartile. 50% of my speeds are less than or equal to 32.5, which is the median. And 75% are less than or equal to the third quartile, which is 38 miles per hour. And then the remaining 25% is up above that. So none of this gets super complicated, but it's still important to listen and all of that stuff, all that crazy stuff. Okay, practice. So here's highway loss data. The Highway Loss Data Institute collects data on collision coverage, so how much money they had to pay out to fix some vehicles. The data on the table below is a random sample of 18 collision coverage claims. That's hard to say, based on data that is obtained from that institute. I already put these in order from smallest to largest. So let's find our quartiles. So you need to find the middle data or the middle value. So there are 18 claims. So your middle value will be between the 9th and the 10th. So go ahead and find that. Right, I got 1805 also. So 1805 is my median. So I'm gonna get my Q3 and my Q1. So since we are 9 and 9, halfway between, so it would be the 5th value would be the smack dab in the middle. The 5th value would be our Q1. 1, 2, 3, 4, 5. So $735 would be Q1. And then the 5th value in the top, 1, 2, 3, 4, 5, and 46.68. Bam. Questions? All right, awesome. Okay, so now that we found our quartiles, we're going to find, is there a way to zoom? What do you mean zoom out? Like, I don't know where you want it to be. Oh, your screen? I don't know. Okay. Uh-oh. Yeah, I don't know how on your screen. So now that we have the quartiles, we're going to use them. So when you have when we use mean, we use standard deviation. When we use median, we use something called the interquartile range. So interquartile range takes Q3 and subtracts Q1. It is the middle 50% of the middle 50% of our observations. So it's just Q1 minus Q3, and it tells us the distance between those two values. So for example, if we're looking at the speed data, I would take Q3, which was 38, and subtract Q1, which is 28 from that. So my interquartile range is just 10. So there's 10 numbers or 10, the difference between the mileage, I guess, the speed, 28 to 38 is 10 miles per hour. So that is my center. That is my, how we determine the spread on when we're using median. So this is like median's answer to standard deviation. It's called the interquartile range. We just abbreviate it to IQR, but this is the word for it. But we just abbreviate it to IQR. So let's do it with, oh wait. So well, I want to kind of show you how the standard deviation and the mean are more impacted by outliers. So we have a car. It yeah, it's kind of used the same way as range, but it's the center 50%. So it's specific to that center 50%. So if I had a 15th car go through the zone, the construction zone, and it's going 100 miles per hour, that's an outlier. So take a look at the difference with using mean and median when you have an outlier. So when with mean, that outlier caused my mean to go up by 4.6 miles per hour. So that mean increased by 4.6. My median, it only moved by 1/2. My standard deviation, look at the difference there. The standard deviation increased by about 12. So it's a lot bigger. It is a lot different. It was highly affected by that outlier. My IQR here, it only changed by 1 mile per hour. So basically, if we're dealing with data that is skewed, if you're dealing with data that is skewed, you use the median. If you are dealing with data that is normal, if it's symmetric, then we use the mean. And this kind of shows you that. And we already talked about that a little bit previously, but this is kind of backs that up, backs that claim up. So it is definitely a big difference. Quentin, I've never even seen your face, so I have no idea. Not that I would say anything regardless either way. Besides, I'm probably old enough to be your grandma. I am an old lady. All my gaggle of grandchildren. And one more on the way. All right. You look like a silhouette. All right. Okay, let's move on. So the way that we look for outliers when we're dealing with median is we're using the IQR and we create something called fences. So our lower fence, you take Q1 and you subtract 1.5 times whatever your IQR is. And that gives you a lower fence. Any data lower than that lower fence is going to be an outlier. And then you're going to take your Q3 and you add 1.5 times the IQR. That gives you your upper fence. Any value higher than that is going to be an outlier. When I math it out, it's going to make more sense. So outliers are any value that is more than 1.5 IQR lower than Q1 or more than 1.5 IQR higher than Q3. So let's do some math. Maybe. So in the speed data, our first and third quartiles were 28 and 38. So our interquartile range is 10. So I took 1.5. So this right here was my IQR. I took my Q1 and I subtracted 1.5 times the IQR, and it gave me 13 miles per hour. That is my lower fence. That is, any value lower than that is considered an outlier. So I took 38, which is Q3, and I added 1.5 times the IQR, and it gave me 53 miles per hour. So any value higher than 53 miles per hour is going to be an outlier. We don't have any outliers here because we don't have any values lower than 13 or higher than 53. So we don't have any outliers here. And I'm gonna warn you, there are times when you use the interquartile range and you find there are no outliers, but then you use the 2 standard deviation rule and there will be outliers. There's just 2 different methods of testing, and there is a little bit of variability between the 2. So it can happen. You can find an outlier one way and not the other way. It can happen. It doesn't happen a lot, but it does occasionally happen. Questions before we do some more math? All right. We're going to use the collision loss data. So my median for this was 1805. And that didn't even matter. I don't even need that. My Q1 is 735. 735. And my Q3 is 4668. So let's math this out. So I'm going to do, for my IQR, I have 4668 minus 735. 4668 minus 735. My IQR is 3933. Sorry about the delay. I think the lower battery causes things to delay. This is my IQR. So I'm going to take 1.5 times the IQR and add it to Q3. So it's Q3 plus 1.5 IQR. So that is 4668 plus 1.5 times 3933. That number does not look right. What did I do wrong? Uh-oh. What did I do wrong? I did something wrong. 4668 plus 1.5 times. Yeah, I got that too, even though I show it's 10,035 on my paper. So I must have done something wrong on my paper. 567. I'm wondering what I put on my paper. Hold on a second here. Oh no, that's so weird because I have the right number. I have the right number in a different spot on my paper. Okay, so this is my upper fence. Okay, so the lower value, so I'm going to do Q1 minus 1.5 times the IQR. So I'm going to do 735 minus 1.5 times 3933. Don't be upset if you get a negative number. Even though it doesn't make sense, don't be upset. You're still doing it right. Because we have negative 5,164.5. So my upper fence is 10,567. My lower fence is negative 5,164.5. That value makes no sense, but it is what it is. I'm going to go back a couple of screens. Oh, maybe if it'll let me. Go back, go back. Okay, so take a look here. This value right here is larger than my upper fence. Therefore, that value is an outlier. We have an outlier in this case. Some car got really damaged. Must have been a really nice car for them to pay it out rather than totaling it for $21,000. So we have one outlier. Outlier of 21,147. Questions? If your question is, what's my battery power out? We're at 24%. Even if that wasn't your question, that's where we are. All right. I think we're at 5.0. 4 now or 3.5. I think we're at 3.5 now. Because they're pushed together, I don't think I mentioned that I separated them. Okay. So 5-number summary is important. The 5-number summary just gives you the important pieces of your data. So, and I know that in your homework, there's one problem that gives you a 5-number summary and it wants you to look for outliers. So be really careful. If it gives you the 5-number summary, you already have the median Q1 and Q3. So if you get a 5-number summary, it's, I had a word, when you're 5-number summary, you have those values. So you don't even have to write minimum Q1, median, and Q3 on there. You don't have to write those things. They are, hold on, you don't have to write them because they're already there. I just realized I have to open up don't mind me. There's a method to my madness. So just hold on a second here. Okay, we're good. All right. So let me show you an example of a 5-number summary. So the 5-number summary of the speed data. This is what I needed to do. I need to open up the PowerPoint on my other computer so I can see all of the data because I just, okay. So for the speed data, my lowest value, my minimum is 20. We determined that Q1 was 28. The median of that data, what is the median of that data? It was 32.5. Q3 was 38. And then my maximum, I'm scrolling through it, is 40. So that's all you have to write. You don't have to write, out what they are. If it's a 5-number summary and you know it's a 5-number summary, you know it is always in these places. I'm going to label them, but I'm telling you, you don't have to label them. So this is the minimum. This is Q1. This is the median. This is Q3. And this is the max. So now we're going to look at the collision data. Okay, where is it? Okay, I'm going to scroll through the collision data. Okay, so my lowest on the collision data was 180. Q1, 735. Median was 18 something, 1805. Q3 is 4668. And then my maximum is 21,147. So I said, you do not have to label them. You just write them out. So when you are given a 5-number summary, remember that you already have Q1 and Q3. So you can find the interquartile range. All I would have to do from a 5-number summary to find the interquartile range is just take that number and subtract that number. And I can determine outliers this way as well, because I would see that my upper fence is lower than 21,147. Therefore, I know I have at least one outlier. I can't say for sure that it's only one outlier, but I know there's at least one outlier. Questions on this? All right. Oh, nope. Okay. Okay. So we're going to do a box plot. I'm going to talk to you about the box plot, but then we're going to do one together. That might be what completely kills my battery, but we might actually be able to get through the lab because I still have 20%, so I might still be okay. Okay. A box plot, first thing you need to do is you need to find your fences and you need to find your quartile 1, your quartile 3, and your median. You need all of those pieces. So This is instructions here, but I'm going to walk you through it instead of just having these steps, because giving you these steps without walking you through it is going to make no sense at all. So I'm going to just go on to the next page, and you can keep these for your own reference later. Okay. So I have some data here regarding credit card issuers. There's a whole bunch of data. This is their interest rates of different credit card issuers. So I'm going to do a box plot here. So right here, this right here is my Q1. This is Q3. And this is the median. These right here are my fences. This right here is where we said anything beyond those values is an outlier. The whiskers only go to the last data value inside the fence. I'm going to put an arrow there. Last data value inside the fence. So your whiskers, and that's right here too, your whiskers will not go all the way to the fence. Your whiskers go to the last data value inside the fence. Lastly, this is the outlier. The outlier is indicated with an asterisk. That is the outlier right there. Underneath your box plot, this is just a standard number line. It should not be what the data values are. The number line shouldn't just be your data values. It is just a standard number line, but make sure that your data values are included in what the number line looks like, or in the values on it. As in, if I had something like a 10.35, I need to make sure that my number line has 10 and has 11. That makes sense. So it's just a standard number line underneath. So before we create one on our own, are there any questions here? Anything that's not clear? Okay. I highly recommend you draw this with me. As I'm drawing it, draw it with me. I think it's going to be helpful. I'm going to go to the next page where we're going to have a nice big empty space. Now, I know what increments to do this number line in because I drew it the wrong way a whole bunch of times before I figured out what works. So I'm going to make a super long number line. Oops. Okay. I'm going to make a super long number line. Hold on here. I learned something cool with my this software today, that it will make the number line straight. Look at that. Isn't that cool? Okay. It made it straight for me. All right. Even though it's lopsided, but whatever. Okay. I know that I need to count by thousands. I write the number by thousands, but I'm kind of counting by 500s. So 0 is right here. 1,000. 2,000. I'm going to show you something kind of cool in a second, even though I think it's cool. Okay, last one inside the fence. There's this thing called a break in the graph. So there's a lot of difference between where our fence is at 10,567 and where our outlier is at 21,000. So you can do this thing called put a break in your graph. Let's see here, I need it red. So when I put, this is just a break in my graph. What this is telling me is that I cut out a whole bunch of numbers. And I know it looks like a W, but it's just basically a line right there. So it's telling me I cut out a big section of my graph. So if you cut out any section of your graph, you need to put that squiggly line right there. So then I'm gonna pick up at 21,000. There we go. So I put a break in my graph and then I went to 21,000. Okay, so now what you do is you put a vertical line above your graph where the median is. My median is at 1805. So it's right about here. And it doesn't have to be exact. You just vertical line about where your median is. Then you put a vertical line where quartile 1 is. It's 735. So it's right about there. Then you put a vertical line about where Q3 is, which is at 4668. Go. And we make that our box. It's not the most beautiful box, but it's a box. Before I do anything else, I need to put my fences on my graph. So I have a fence at negative. So usually what I do, it's way off over here in the negative. I just throw it over there. And sometimes I'll label it. It doesn't matter if you label it. But sometimes I'll just throw it over there and I'll label it. If you don't label it, it's fine. It's just way off there in the negative. It's pretty much insignificant. But my upper fence is important. So it's a 10,500 something. So my upper fence is up here somewhere. Uh-oh, that's not what I want. Let's undo that. My upper fence is up here somewhere. So now whiskers. The whisker goes to the last data value inside your fence. My lowest data value inside my fence is 180 on the left. So we're just gonna have to kind of estimate where that is. It's right about there. Probably a little bit further than that, but we're gonna call that good. The last data value inside my fence on the upper side is 10,034. So I'm gonna draw a line all the way up here to basically 10,000. So all the way up to 10,034. That's the last data value inside my fence. Finally, I need to indicate the outlier. I have an outlier at 21,147. So I'm going to put an asterisk where my outlier is. And there we go. We made a box and whisker plot. Now, if you have any questions, this is a good time to ask me questions about this beautiful masterpiece of a box and whisker plot. Yeah, it does kind of, you're right. So it's a beautiful masterpiece. And you may be able to tell that this is right skewed because the whisker is longer on the right than it is on the left. So this is a right skewed graph. And it was smart to use median for this because it is skewed. Any actual questions? All right. So I just want you to kind of see what a box plot looks like compared to the I can't even speak, compared to the histograms. So look at how the right skewed histogram and how the box plot looks when it's right skewed. Notice how the symmetric one, the box is pretty much in the middle. The whiskers are very much the same size or really close. And on a skewed left, the box is more to the right and our whisker is longer to the left. All right, this is the last of our, that's the last PowerPoint. Look at that. We made it through all the slides. I'm really happy. Okay, that was our last slide. If there's any questions regarding the slides, now's a good time for that. If not, you like the box and whisker plot better than the histogram? I mean, it's there's something elegant about a box plot. What I hate is that that when Excel makes box plots, they make them vertically, and I don't really like them. But yeah, they make them vertical, and it's kind of ugly. However, your calculator can make a box plot. I'm probably not going to show you that today, but I am really quick. I'm hoping. So I'm gonna get rid of my iPad off of here because it's taking up a lot of the battery. But I'm going to show you I want to go to the calculator. Let's go to the calculator. So I'm going to take this off. No more iPad. And I need to move stuff so I can actually get to my tabs. What? Okay. We're just going to do this. So I'm going to try to get to my calculator. Hopefully I will actually be charging now. Oh, we're at 21%. Okay. If it'll let me, if it won't let me, I'll do it on my other computer, but it should let me. If I still have 21% of my battery, look at that. I mean, if it was my daughter's phone, she would be like, I don't have to charge it for hours. I don't understand. I mean, I'm one of those people that it gets to 80% and I'm like, oh no, I got to put it on the charger. And then my daughter is oh, it still has 6%. I'm good. I actually have two daughters. I have two sons and two daughters. My son actually graduated. I don't know what happened here. My son actually graduated from the nursing program at RCC. He currently works in the ER at the hospital in Grants Pass. He's an RN. He's amazing. All four of my kids are amazing though. Okay. All right. So I'm going to put in the collision data because not the collision data. I'm going to put in the speed data because it is easier. And real quick though, I'm going to show you if you deleted your, I mean, I don't know who would do it, but if you happen to delete any of your else, I'm going to show you how to put that in there since I'm here. I'm just kidding. I'm just picking on you. Yep, exactly. It's at 3%. Like, oh, maybe I should charge it. All right. So let's go to edit and then go to our L1. Let's say that I accidentally, I don't know who would do this, but you accidentally hit delete instead of clear. I'm going to clear this one though, because it's annoying. It's like, oh no, I hit delete. I don't have an L1 anymore. The way to get your L1 back, see right above delete is INS, which means insert. So if I hit second insert, then I can name that L1. Then you do second L1 and it names it L1 and it brings it back. So you do second delete and then it will insert one there. And then you do second one to get the L1 back. And you can do that as many times as you want. As many as you need. All right. I'm going to put in the speed data here and I'm going to do it speedily. I hope I'm going to do it speedily. $39, $40, and $40. Okay. And this isn't really anything. Yay, you got them back. Good. This isn't anything fancy or brand new. It's just now that we have more vocabulary, we can use that vocabulary. So we're going to go to stat and go to calc, and we're going to do our one variable statistics. And I don't want frequency. Frequency is clear. I want my list to be L1. Go down to calculate. So we were here before. But now we know all of this stuff here. So it gives you your median, your minimum. You're welcome. Gives you your minimum. It gives you your Q1. Gives you your median, your Q3, and your maximum. This right here is your 5-number summary. These 5 numbers right here at the very bottom are your 5-number summary. So this is exactly what you need if I'm asking for a 5-number summary. So I just wanted to make sure that you could see those were down there because I told you that we would eventually get there. And we did. Yay! Okay. So now we're going to go to the lab. So what I'm going to have to do is I'm going to use both computers because different computers. Okay, so we're still at 21%. It's holding steady now that I removed my iPad. This is not the right lab. Where did you go? Okay, there it is. So this is lab number 2. You can use your, you can use your continuous data from lab 1 if your continuous data was really continuous. I don't think anybody didn't use continuous, but this is just part of my speech. The idea here is that you're using the Excel tools for pretty much everything. So I want to see Excel tools used everywhere. All right, so I need to move my little toolbar up here if it lets me grab it and move it. I need to move my toolbar. 1 second. Okay. So the first thing that you need to do is you need to make sure that you have the data analysis tool enabled. There's 2 different ways to do it depending on what kind of Excel you have. I'm going to show you both of them because I have 2 computers that have 2 different ways. The first way is the less common way, but on my MacBook, this is the way it shows up. So if you have a MacBook, it might show up this way on your Excel. I don't believe this works on the web version of Excel. It might, and I could be wrong. So you may have to have it on your computer or use one of the computer labs at RCC. Anyway, yeah, it's still 20 entries, but I'm crazy, so I have 5 million. So yes, still you only need 20 data values, just whatever you have is fine. All right. So to enable the data analysis tool, I'm going to go to data up here at the top. Oh, my data analysis tool is already enabled. Okay, I'm going to unenable it. So if it's not enabled, if you have the same kind as mine, if your MacBook shows up the same way as mine, if I look over here, it says analysis tools, and then it's empty underneath. I don't want that to be empty. So I'm going to click on analysis tools, and then I'm going to click on analysis tool pack. This is what I want to enable. I'm going to click OK. And now notice it says data analysis. I have the tool that I need. Now I'm going to stop sharing, and I'm going to share on my other screen. Give me 1 moment. Or maybe longer than a moment. So I'm going to share this screen. I want the Excel. Okay. So now I'm over here. Hold on a second here. Okay. Okay. So over here on this computer, I do not have the data analysis tool enabled. I need to get rid of that. Okay. I do not have the data analysis tool enabled. Why is my, okay. Everybody should be disappearing off my screen. They're not. Okay. Anyway, so on this one right here, you go to File. This is the normal one. This is what most people probably have. Go to File and go all the way down to the bottom to Options. I'm clicking on Options. I don't want these. How do I get rid of the people, the view? Let's do View. I don't want anybody. I don't know how to do that. I don't know how to get rid of the people on the side, even though I love seeing your faces, but I'm just trying to not show everybody on the Zoom recording. Anyway, so on down to the bottom, we want add-ins. So once again, if I confuse you, File, Options, and then you want to go to add-ins. So down here, it says Manage Excel Add-ins. Click on Go, and you want the top 2. So click on the check boxes for the top 2, and this will enable your tool pack. You're going to click OK. And then when I click on data, I have data analysis over here on the right. After you do that, all the rules are the same. Everything is exactly the same. So I'm going to stop sharing my screen. And we'll go back over here. That is really sad, Quentin. Yeah, it takes a little bit. Takes a little bit. So I'm going to share the screen again. And we're going to go back to Excel. I want to do my whole desktop. And okay. Now we're back at Excel. Get rid of this. Okay. So the first thing we're going to do is you're going to click on your data analysis tool right here now that we have it. And scroll down, because what I want, actually scroll this way, scroll up, whatever. I want descriptive statistics, whichever way you're scrolling. You want descriptive statistics. And then you click OK, and this box pops up. My input range is all of my data. So you just click and drag until everything is highlighted. And of course, I have a massive amount of data because I'm crazy and weird like that. So we're just gonna wait. Need some hold music or something. Okay, got some hold music. There we go. So that's my input. The output range. The output range is this lovely little box that I have up here. And I'm just gonna highlight. I don't need the whole box, but I'm just gonna highlight it. That's gonna be where I want my output to land there. I want the whatever information they give me, I want it to land there. If you don't give an output range, it's going to throw it on a different tab. And weird things are going to happen. Okay, now I'm going to click on OK. Do I need this one? I do. Sorry about that. Before you click OK, I want summary statistics. Check that box to get summary statistics. Now click OK. Look at this lovely stuff right here. It gives me the mean, gives me the median. I have the mode. I have the standard deviation, and it gives me my range, the minimum, the maximum, adds them all together, how many I have. It gives me a whole lot of information. Okay. Now I know that you are capable of typing values into these boxes. However, the point of doing these labs is to use the Excel tools. Therefore, this is how we're going to enter the stuff into the yellow boxes. And I click on the mean box, and I click on equal, and then go over here to your new table that you have and click on the value that you got for the mean. So that box right there that's now has this dots around it. And then when you hit enter, it's going to populate that. We're going to do that again for standard deviation. Click equal and go over here and click on the value that came out for standard deviation and hit enter. I'm going to come back to number 2. I'm going to do the same thing with the median. I'm going to click equal, go up here to the median, hit enter. Same thing with the mode, equal, mode, enter. And I know that, especially with a number like the median, that's just 7, it's kind of tedious, but the purpose is to use the tools. You put your z-scores should be on number 2. That's where the z-score should be, and it's fine. Okay. All right, so in number 4, you're just going to type something out. What I'm looking for is for you to say, my mean and my median are really close. Therefore, my it's in the week 3 materials near the bottom is where the link to lab 2 is. Okay, so on number 4, I want you to explain that my mean and my median are really close. Therefore, it's symmetric. Or you'd say, you know, because this one's bigger than this one, it's right skewed, or because this one's smaller than that one, it's left skewed. I want you to talk about the relationship between the mean and the median and what that says about skew. Yes, I know there's a number right over here in skewness that can give you that answer, but I'm really looking for your understanding of when the mean and mean are close to each other or far from each other, what that means. Okay. Yeah, you can resubmit it. Yeah, it's not due until next week, Tuesday. So you're more than welcome to resubmit if you need to. Okay. So on the low, once again, click equal and go down here to the minimum, enter. I'm not going to do Q1 and Q2 yet. Q2 is median. So I'm going to take it from this box. Why not? And the high, equal, maximum. Let's talk about quartiles. We're still going to go back up to 2. Don't worry. So the quartile thing is kind of cool. So I can put equal right here and I can type in the word quartile. Take a look. Quartile right there. What I'm looking for is I want to know the quartile of all of my data. So I'm going to highlight my data again. Highlight my data. I've entered too few arguments. What? Okay. All of my data. And then, comma, I want this first quartile. So I'll put 1. and then close my parentheses. So quartile, where your data is, so highlight it all, comma 1. That's going to give me my first quartile. For quartile 3, put equals quartile. Once again, all the range of my data. You seriously could just copy and paste from the first one and then just change it to 3, but I'm kind of extra. So there's my range, comma 3. Close my parentheses and hit enter. I want you to use these tools because that's what we are learning here, is how to use the Excel tools. Sometimes it's a little overkill, but you know, that's what assignments are. Sometimes they're overkill. On your interquartile range, I love that Excel does math for me. I can hit equals, and I want this box minus this box, and then just hit enter and it will subtract it for me. So that's what I'm looking for. When it comes to question 2, I am not requiring you to do the math in the cells unless you want to. What I want you to do is I want you to reference the z-scores, or you can use the 2 standard deviation rule. This is the place where we are not using median. I want you to either find the 2 values that are 2 standard deviations away from the mean and say, look, I have none below that, or I have none above that. Or you can calculate the z-score of your highest and lowest values and tell me whether or not they're outliers. I need you to give me some indication with justification of your searching for outliers using the 2 standard deviation rule. So what I could do if I wanted to, I could do take my lowest value, and I could do this. I could do equals my lowest value, which is this one, minus this one, then divide it by the standard deviation. And that gives me a z-score of negative 2.408. I could put this as lower. And then I can do, if I wanted to do my upper now, I could do the math in here if I want. Remember, if you're doing math in Excel, you always have to put in equals first. Equals parentheses, I'm going to get my highest value, minus the mean, divided by standard deviation. Bam. So that one is also an outlier. So I have an upper and a lower outlier. If you wanted to, you can do that in Excel. And then you just type your words here and say, both my upper and lower are outliers, yada, 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 whatever you want to say. Questions about the lab? Bet you I still have some. Look at that. I still have 21%. Unplugging the iPads was what I needed. So, questions about the lab? I love this lab because I really like the data analysis tool. We're going to use it again in lab 5. It's really super useful tool, and it could be really helpful when we get to our final projects. Don't worry about your final project yet. I'm just saying that data analysis tool, it's a really great way to just kind of have everything in one nice little spot for your final project once you have all that data and everything. It's going to be super useful. So that's all I have for you today then. And look at that, my computer's still going. So I'm going to turn off the recording, and then any questions for not recording, we can ask those.